Hello, my name's Mike Taulty and I work at Microsoft in the UK. And this is one of a number of videos around a technology called Prism, sometimes known as the Composite Application Guidance. This comes from the Microsoft Patterns and Practices team and largely targets building Silverlight and WPF applications. But you can use some of the techniques and the pieces delivered outside of those spaces. So you kind of get two things with Prism. You get some documentation and you get some libraries in the form of source code that you can build up for WPF or Silverlight. And as I say, you don't have to use these inside of those kinds of applications, but some of the technologies in Prism are specific for UI work with these two technologies. Prism has a friend called Unity, which is another framework, and we'll talk about that as well in these videos. And in terms of finding these things, if you want to find Prism and so on, if you just pop to a search engine, type in Prism and Codeplex and you'll find Prism. If you want to find Unity, type in Unity and Codeplex and you'll find Unity. If you want to find these videos, you can go to channel9msdn.com/niners/mtaulty, that's me, and I'll put these videos on this site here. If you want to find me, you can go to mtaulty.com, that's my blog, and you'll find it there. If you want to find me on Twitter, you can go to twitter.com/mtaulty and you can find me on there as well. And if you want to find me on email, I'm just mtaulty@microsoft.com. And so in this video, I'm not really intending to get to Prism. I want to just make a start, and we won't even be building a Silverlight or WPF application in the first instance. What I want to do is just to sketch out some code that'll be pretty rough and very simple. But the idea is just to get us to a point where we can start to then manipulate or refactor that code towards making it a little bit more elegant, a little bit less coupled, a little bit more modular, and we can start to introduce some of the concepts around using Unity and then onto Prism. So in this video we're just starting off something just to keep the video kind of short, and then the next video we'll start to refine it a little bit. The video after we'll start to bring in using Unity for some things, and then move towards modularity in Prism and keep going and keep going and keep going until we run out of steam and perhaps have to switch to a different sample, a different example in order to continue moving along. So that's what we're really going to do here. Where I actually want to start is just by working in a simple console application, just to sort of build things up. I want to make a number of videos that kind of refine the points that I want to talk about as we go along. And so rather than starting in Notepad or in a Silverlight application, let's just spin up Visual Studio and let me just full screen that thing. And let's do File, New Project in here, and rather than a Silverlight app, in the first instance, let's just go for a console application. I'll give it a grand name, I'll call it Application. That seems like a good name for it. And let's click OK on that, throw it into CTemp. So here's my application. Now imagine I'm writing a program, and we'll keep it pretty simple. Let's imagine that I'm writing a program that is a kind of read, evaluate, and print line loop for a calculator. And let's just start off and naively write that program, just all kind of here in main, in a single executable, and even perhaps in a single source file. Let's just go that way. So probably what I want is for my calculator to have some commands. So let's say static string, let's say commands equals, let's say add, multiply, divide, and subtract. I suppose subtract should have come back there really, shouldn't it? So let's put subtract just there, something like that. Great. Okay, so we've got a little array of commands. And let's have some functions as well. So let's have static int add, and that might take int x and int y, and in time-honored fashion, let's return x plus y from there, not testing ourselves too much. Let's write static int sub, int x, int y, and let's go and return x minus y from there. And let's also have static int mul, I'll have int x, int y, and we'll just return x times y from there, and then finally static int div, int x, int y, and we'll return x over y, not caring at all for overflows or divide by zeros or anything like that. Don't care about that right now. And maybe what we'll also have is a static list of sort of function pointers of delegates. So we'll say static, I want funcs of returning int and taking int and int, and we'll call those, let's call them funcs. We'll make that into an array, and that's going to have add, sub, mul, and div. Those are my functions. You can probably kind of see where this is going at this point. I guess we have to go ahead and make that into a proper array. Missed out some braces. Fantastic, so we made it into an array. So great, let's write a sort of read eval loop. So we'll just say while true, let's not leave the user any chance of escaping from this. Let's say string input equals console.readline. That will be the input command that they want to execute. And we'll say if commands dot contains, we'll not worry about case, input, then great. Otherwise, let's write an error. So we'll say console.writeline mistake, something like that. And then what we need to do is figure out which of those commands it is. So we'll say, let's say index equals array.index of. Let's look for, in the commands, let's look for the input. And we assume that we find it because we already did the contain. So let's say what we then need to do is call the function. So we'll say int result equals funcs index with, we need parameters. So let's go and read those parameters. Let's say int x equals int.parse console.readline. And let's say int y equals int.parse console.readline. Could have written some functions here, I guess. And finally, we'll just go and call that function with x and y, and we'll then write that to the console. Let's build. Let's run. Let's say add 20 and 30 is 50 mul. 90 and 110 is 900, etc., etc. There's no way out of this program. Make a mistake, we get a mistake, we can control C. Alright, so we've written some code. Perfectly good code in as far as it goes. Probably not how most people would write this code in one big function here, albeit with the 4 that we wrote for our little operations as well, and then these guys down here. But, you know, it's a starting point, and it kind of works. But I suppose the thing is that all the functionality is kind of contained in main. There's not really much here that we've made that would be reusable outside of this particular program. We just have one class and we have one executable doing the reading of input and the calculation functionality and the writing of output. And so probably what we do is refactor this to be a little bit more sort of object oriented. I'm not going to say that I have the one true way of doing that. I think there's probably 1,000,001 ways that you could refactor this, but let's start to write some classes. So let's move over to our solution over here and let's add some classes into it. So we'll add a class. I'll call the first one calculator. That's probably not a bad idea. So let's say calculator. Where is it? There we go. So here's calculator, and let's just go back to our program. We'll state these static functions, snip them from here and drop them over here, except they won't be static, they'll be instance methods over here. So we'll just say public int add, and we'll say public int sub, public int mul, and public int div. So okay, so that's great because we can now at least have our calculator that does that kind of work for us. And let's go back over here, and let's also perhaps go ahead and have something that knows how to, I guess we need some kind of class that wraps up these arguments. So let's go back over here and let's have a new class. We'll call it arguments perhaps. Arguments, simple class, just put a property on there for x and a property on there for y. That's the argument class. Perhaps we'll refactor that and just call it arguments. Maybe we should have called it binary arguments. I don't know, but that's fine. Let's make it public as well while we're here. And perhaps the same with the calculator class whilst we're there. Okay, so we've got a class that does that. I'd like a class as well that does the reading of values from the console. So let's go and have a class that does that. Let's add a new class. We'll call this something like input service. Console input service is perhaps a better one. Console input service.c#. And we'll make that a public class for the minute. And we'll say public string, let's say read command, something like that. And all that's going to do, of course, is return console.readline. And let's also have public arguments read arguments. And all that's going to do is say int x equals int.parse of console.readline. And we say int y equals int.parse of console.readline. And then we'll return a new argument where, let's just fill that in, x is x and y is y. Okay, so we've got something that does that. That's our input service. I guess we should also have a console output service. So let's go ahead and add a new class. We'll call that console output service.c#. And so in here perhaps we'll make this a public class as well for the minute. and let's say public void write message string message, something like that. And in there all we're going to do is console.writeLine of that message. So that's fine, we've got that class as well. Let's go back to our main program over here. We're not far away from this. We also need something that can evaluate what the valid commands kind of are for the application. So perhaps we'll have an enumeration of these different commands. So let's go and throw that in. Let's add something like command types, something like that. Let's call it command types. Not a great name, perhaps that, but we'll go for it anyway. And let's make that just a public enum command types, and we'll have add, sub, mul, and div, something like that. And I also feel the need for something that parses a string into one of these command types. It's just a wrapper over enum.parse really. But let's go ahead and say, let's add another class. We'll call this command input parser. And let's call it input parser service, something like that. Sounds a bit grand. And let's just make that public again. Whoops, nearly. And this will provide a property. So we'll say public command types. And let's say parse command, string command. And all we'll do there is we'll simply say, let's try and do return command types enum.parse of that command types and the value that actually gets passed in. And so that's fine, we've got that in there as well. That's the input parser service. And then finally, I guess back on my calculator, I feel the need for a different method on here just to make things easy for myself. We'll have a public int, let's call it execute, and it will take a command type, so let's say command type, and then to say int, oh no, of course, it takes arguments, doesn't it? So let's make this an argument, and we'll just say args, something like that. And actually what we'll do is we'll change all these to take arguments as well, I guess. So we'll just say arguments, args, and that just has to return args.x plus args.y, of course. I have to go through and just fix that all the way through this stuff, so let's just go and make that arguments args, and that's going to return args.x minus args.y. And then we've got multiply, which takes arguments args.x times args.y, and then we'll have div, which takes arguments, and that's going to return args.x over args.y. Okay, great, so we've now got execute, and I suppose we could do something clever, but let's just throw a switch statement in here. We'll just say simply switch on command type, throw those in, and let's just say return add on args, and let's say return sub on args, and let's say return mul on args, and let's finally say return div on args. And I suppose here we should also just say throw new invalid operation exception, something like that. My code has obviously got in a big mess because it's not formatting itself properly. Let's just go and see what I did to it. Let me see if I can build it. Aha, okay, let's just fix that code. Well, that's okay, we'll come back to that in a second. Let me just go back to my calculator for a second, reformat that code for you so it looks nice. So we're just doing a switch statement, and of course we've got unreachable code here now, which is a bit naughty, so let's get rid of that. And let's get rid of all of that. Great, so I just feel the need for one more class in here, something that actually would execute the REPL loop for me, so this kind of thing here. So what we'll do is just write that class. Let's just go and throw that in. We'll have one more class, and we'll call that something like calculator REPL loop, something like that. And we'll just put that as public, and we'll say public void run, something like that. And then what it's going to say is while true, what we need to do is go and read the input from the console. So what we'll do is we'll put on this class, we'll have an instance of the console input service. Let's just do that. Let's call that input service. And let's have one of the console output service. We'll call that output service. Let's have a calculator. We'll call that calculator. And let's have an input parser service as well. We'll call that input parser. And I suppose on our constructor up here, let's just make all those things. So let's just say calculator equals a new one of those. Let's say input service equals a new one of those. Output service, equals a new one of those. And what's the final one that we've got? The input service isn't there yet. Let's go and do that as well. New one of those. Great, so we've made these 4 services. And so what we can do down here is we can say command equals input service dot read the command. That's great, so we've got that command. And then we need to try and parse that, so we can say try, I suppose, and catch. I'm going to be evil there for a minute. Let's just say try of command type, let's say command type equals, let's use the input parser service dot parse command, and we'll pass it the command that we've got. Actually, we could do this a better way, couldn't we? I think on our input parser service. Oh no, that's right, we just had parse command. We could have put a method on there to tell us whether it was valid or not. Let's just write out mistake again like we did before. Great, so we've now got that in place. And then once we've got the command type, what we need to do is use the output service to write a message to the console, and that message is going to be the results of calling calculator.execute, and we pass it the command type, and we pass it the arguments, which we haven't got just yet. So let's say arguments args equals input service dot read me some arguments. Pass the args there. Great. And so we should be, I don't know if we oh yes, we probably need to convert that to a string, don't we? Let's just do that. Great. Let's just go back to our original code. So our original code in our program now just becomes static void main. We make a calculator REPL loop. New one of those. And we say loop.run, and we're done at that point. Let's just see if we can build. So we're making that instance of this thing. In there what we do is we use our input service to read a command. We pass that into our parser service, which parses it and gives us a command type. We read arguments from our input service to get arguments. We then ask the calculator to execute that command type with those arguments. We use our output service to write that to the message, write that message out. And in fact, we should have used the output service here as well to write that message if we failed. Let's build. Let's run. Let's try add of. Oh, we already got it wrong. Was it add like that? 10 and 20. Let's do mul of 30 and 50, and so on. We've got our code working again. So arguably, this is a more neatly structured and slightly more object-oriented, you could probably argue about the way they've actually done it, piece of software than we had before. It's reasonably nicely broken down in that we know the bit of software that runs the loop. There's the component that does that. We understand that this has now dependencies on these various different services, input, output, calculator, and parser. And they're all in separate little classes that we know about. They're all doing fairly simple things. And some of these things are now, if you imagine, reusable. So we could potentially reuse this console input service in some other program. Similarly, we could reuse the calculator in some other program, as long as we had the command types and the arguments type with it. It's possible now to reuse that thing in some other program. Unfortunately, the way it's packaged right now in this one big assembly isn't going to make it very reusable. So probably what we'd want to do next is move this stuff out towards separate libraries, such that it actually becomes more likely to be reusable at a binary level by some other programmer. So let's do that. Let's refactor this out into separate libraries, having refactored it out into separate classes. Okay, so closed a few windows there, and let's go and add a few library projects into this and start to divide up what we've got. So let's say add a new project in here. We'll go for a class library. We'll call this one common types. That's a bad name really, but we'll go with it for now. Let's do that. Common types library. Let's get rid of the class that Visual Studio has thrown in there, and I probably want to move my command types. Let's just cut that out of here and drop it into this library here. Let's just paste that in there, and that means that my application is probably going to need a reference to that in the end, but we'll figure that out in a second. So we've moved that over into this common types library. Let's then go and move our input parsing and perhaps our input and output into another library first. So let's add a new library here. So we'll call this one input output library, something like that. Make that a class library, close this guy down. Let's get rid of that class that was thrown in, and let's take input and output. We'll cut those and drop them into this library here, so let's paste those in there. Okay, great. So they're now in there. Let's add another project into the solution. So we'll do add new project, another class library. Let's call this the calculator library, something like that. And into there, again, let's get rid of the class that Visual Studio throws in. And let's throw in perhaps the REPL loop and the calculator, cut those out of there. And I've just realized that my argument class really belongs in that common types as well. So let's put these into the class, into the calculator library. And let's take that argument class, cut that out, and drop it into the common types library as well. Let's just paste it in there. Those are really just really simple types. And then I suppose also there's the need for input parsing. So I don't know whether that should really go in the into the input-output library. It feels like it shouldn't really, because it's not to do with the console in any way. So I'll throw one more library project in for good measure. So let's just call this one calculator parsing, I don't know, command parsing library. Naming's not too hot here. And let's just get rid of the class that Visual Studio throws into that. And let's take this input parser, chop him out of there, and drop him into here. Okay, so we're going to struggle now to try and build, because obviously lots of things have are missing references. So let's go to the calculator library. Let's give it a reference to the common types. So that's that guy there. Let's go to the well, let's see what else doesn't build. Let's kind of go around it that way. Input-output library knows how to read an argument. So let's go to the input-output library and give it a reference to common types. And let's go rebuild. Calculator library doesn't know about the input and output service. So let's go back to the calculator library and add a reference to the input and output service. Let's build that. Calculator library doesn't know about input parsing. That's for the REPL loop. So let's go to our calculator library and add a reference to the input parsing. Build that. And our parsing doesn't know about the common types either. So let's go to the parsing, add a reference to the common types. And then our application doesn't know about the REPL loop. So let's go to the application and add a reference to the REPL loop, which is in the calculator library, and rebuild. And I think we're back in business. We can run our code, hopefully, and add two numbers together. Great, so we can still do that. And so now, not again necessarily meant to be perfect in any way, shape or form, but we've now got our stuff factored down a little bit, such that we've got the application, which just has a reference to the calculator library, and then in there we've got the calculator itself and the REPL loop. That then references off to common types, input, output, and calculator parsing, and then you know what those other libraries are. So split this down now into separate libraries, kind of making things a little bit better than they were before. Okay, so we're in a slightly better position. But if we take a look at our REPL loop here, if we have a look at the thing that actually does the work, this class is very much tied to particular implementations of calculators, parser services, and input and output. So specifically, we are saying that this class will always use a console input service and a console output service. But what if I wanted to reuse this functionality with a non-console input service and a non-console output service? What if I wanted to change the calculator implementation, maybe at compilation time or maybe at runtime? And it would be very useful for, even for reasons of testability, to be able to plug in mock services here rather than real implementation, so I can work on this component in isolation and test it in isolation. That's very difficult, if not impossible, for me to do with the way I've written this right now. So what would be great would be if we could abstract our calculator REPL loop from the actual concrete types of these things, and maybe feed it the implementation details at maybe compilation time or maybe at runtime, and that would be really quite slick if we could do that. And so we can do that. We could do it via a number of different ways. We could type all these things as object. We could use dynamic creation and reflection to invoke methods on them. It's not something that you'd really want to do in a statically typed language like C#, even though C# 4 and .NET 4 are kind of moving some ways in those directions. But generally speaking, treating things just as objects and using reflection is a little bit too extreme. Probably what you'd want to do is either define a base class for what an input service might look like, and an output service and a calculator and so on, or perhaps an interface that defines what those things might look like, and then allow this class here to be used with different implementations of calculators and input and output services. So let's head off in that direction. Now, we could use base classes or we could use interfaces. For me, I prefer interfaces, and the reason I guess for that is that firstly in .NET, if I force you to pick a particular base class, that's not very friendly, because in something like C# or VB you can only have a single inheritance, so you can only go and inherit from one base class. And so that's not great, because if I force a base class on you, that's not very fair. And the other thing is that you can use one component, of course, to implement lots of interfaces. So using interfaces gives more flexibility to me around the person that actually has to come along and provide an implementation. So what I'd like to do is then take these services that we're using and extract interfaces from them. So let's go ahead and do that. Okay, so let's first off go and visit, say, our input-output library. And I want to create an interfaces project. There's probably a need for more than one, but perhaps what I'll do here is just add a new project for interfaces and just keep one project. So we'll call this interfaces library, something like that. And okay, let's just get rid of the class that Visual Studio creates. Fine. And then let's go over to, for instance, these input-output services. So the console input service, let's go and extract an interface from that, which we could call iInput service. And let's go and make sure we get both of the methods on that, and we'll make that a public interface. And actually what I want to do is chop it from that particular class library and drop it into my interfaces library. I should probably change the namespace at the same time, but we'll not worry too much about that for the minute. I thought I'd cut it out of there. Let's just delete it there. Close a few files. And let's go back over to the output service then and open that. Let's take this guy and let's extract an interface from that as well. We'll call that iOutput service. And let's just include the one method on that. And let's make that public again. And let's also go and cut that file from there and paste it into there. And at that point, even with the namespace is a bit strange, we probably needed a reference then from this to the interfaces library in order to make that stuff work. So that's that one done. Let's look at our calculator library. Let's go to calculator and let's extract an interface from that. So let's go ahead and say refactor, extract an interface from that. We'll call it iCalculator. We'll add all the methods to it, and then we'll go and make it public, and then we'll go and shift it over from here. Let's just go and take iCalculator, cut it, paste it into our interfaces library. Okay, great. Let's close that off as well. And perhaps we'll also do the same thing on the REPL loop. I'll come back to that in a second. Let's go to the parsing library. Of course, this now needs a reference to interfaces. Let's go to the parsing library. Let's take the parser service. Let's go and extract an interface from it. That's all fine, I think. Let's just go and let that happen. Make that public. And let's go and take that, cut it, sorry, that one there, cut the interface from there, paste it into our interfaces library, and make sure we have a reference to that interfaces library from here too. Let's just go build. We've got some bits and pieces missing. Let's just call that perhaps there's a need for our interfaces library to have a reference to the common types. See where we get to with that. See if we can build. Not quite. We're missing a public service somewhere. Let's just go to the definition of that interface and make it public. Just bear with me a second. Let's build that. Okay, so we can rebuild. And so what we've just done is essentially moved our definitions into this interfaces library. And so really now, when we look at our calculator library, let's look at the REPL loop that actually does the work. We can now replace these things. Instead of having specific implementations here, we could make these things into interfaces. So we could use iInput service as opposed to using an actual implementation. And if we want to do that, we could perhaps provide a constructor that by default would instantiate a console input service, but we could also provide a property that might in the absence of a default, you could go and overwrite the default with your own value. So maybe what we can do here is say, let's put some properties onto this thing. Let's get rid of all this stuff, and let's add properties. We'll say property iCalculator. Let's call that iCalculator, and we'll call that calculator. And let's have another one. We'll call this iInput service. and we'll make this guy input service. And of course, output service, we'll call this output service. And then finally, input parsing service, I think it's called. Not sure what we called that. Let's call it parsing service. Let me just go and find that interface and remember what it was called. Input parser service. We should be able to use, so let's just use that guy there. Fix that namespace for a second. And so now, by default, we can say calculator equals new calculator. And we can say input service equals new console input service. And we can say output service equals new console output service. And we can say that parsing service equals new input parser service. And then down here, of course, we can start to use those things. So we use input service here. We can use parsing service here. We can use input service here. And we can use output service there. Calculator here. Output service there. Hopefully we still compile. So if you notice, what we've done is our REPL loop now is a lot more flexible than it was previously. By default, sure, it's going to use calculator, console input, console output, and input parser. But these things are replaceable. So if we came up with a new output service, so for argument's sake maybe a message box output service, then we could plug that in, and I suppose we could try that out. Let's go and do that. So let's just go visit our input-output library for a second. Let's add a new reference over here to system.windowsforms. Just going to throw in a reference to Windows Forms there. And let's add a new class in here. Let's just go and add a class. We'll call it MessageBox Output Service. And onto that, let's go and implement output service. And all we'll do is do messagebox.show with that message. Okay, great. So now if we go and build and go back to our program, let's go to where our program is. Let's say loop.outputService equals new message box. I don't know if we've actually got a reference to that library to make that happen, so let me just add a reference for a second to make that happen. Because I don't really want this reference in here, but let's just add a reference for 1 second. Did we call it message box output service? And did we make it public? Let's just go and add that namespace. So now our loop is using a new message box output service, so when we presumably go and run it, let me just make sure we've got a reference to our interface library. Then we add 10 and 20, and we get 30 in a message box. The point being that now our calculator REPL loop is far more divorced from its output service than it ever was before, and we've made this thing effectively a parameter of the type that we can provide at compilation time in this particular case in order to change the way that this thing works. So if we go back to it over here, we've now nicely abstracted away the calculator REPL loop type from the actual type of the calculator, the input service, the output service, or the input parser service. Now that's great, but what we've done is we've moved things on a little bit. We've made it so that this calculator REPL loop can have different services plugged into it effectively at compilation time. So at compilation time, a programmer who's using the calculator REPL loop can decide to change the output service from a console output to, for instance, a message box output. They just write an extra line of code to set the property. That's great. That's at compilation time, though. They may want to control this at runtime. They may want to decide at runtime, hey, I don't want to use the calculator REPL loop with an actual message box output service. I want to substitute in some kind of mock object in order to do some testing, or for this particular configuration on this particular machine I want to use message box, on that other machine I want to use console, whatever it might be. But we might want to do these things dynamically at runtime. And in order to do that, you could imagine that perhaps what you would have is some kind of component that manages a set of implementations for interfaces like these, calculator, input service, output service, and so on, and provides the right implementation at runtime. And specifically, as you're creating types like this REPL loop here, it would be great to have a service here that we could look up what is the right implementation to actually use. What would be the right implementation to actually use? And so we'll snip the video at this point to keep it short, and having moved our code into this particular form, we'll come back in the next video and look at how the Unity framework does that for us, provides that service for us. And the Unity framework is not something that Prism actually absolutely depends upon, but in its default mode it uses it, and chances are you would probably use it as well. So we'll take a look at how that works inside of the framework that we've got here right now, and then we'll move on in subsequent videos beyond Unity and into more pieces of Prism. But let's snip this for now, and we'll come back in a subsequent video and take a look at how Unity fits into the code we've already got.